Ever feel like you're just staring at a mountain of information, wishing there was a fast way to know if it's even, worth climbing?
Yeah, like, is this thing actually useful? Or am I about to waste my time?
Exactly. That feeling, that need for a quick filter, that's kind of the core of what we're exploring today. But in the world of software, we're diving into something called smoke testing.
It's basically a quality check right at the start. Think about buying a new gadget.
Yeah.
You'd probably plug it in, see if it powers on, right?
Yeah.
Before you spend hours reading the manual or trying every single feature. Smoke testing is kind of the software version of that first power on check.
Right. And one of our listeners sent in some great stuff, articles and notes all about smoke testing. And honestly, my first reaction was, sounds pretty techy.
It can sound that way, yeah.
But here's where it gets really interesting, I think. It turns out it's actually a pretty intuitive idea. There are some surprising parallels to how we check things out in our everyday lives. So our mission today, let's try and break down the essentials of smoke testing, understand why it's so vital in software development. And trust me, there are insights here that will probably click even if you've never written a line of code in your life.
Okay, let's unpack it. So at its heart, smoke testing is a really rapid assessment. You got a newly built piece of software, and you need to know, is it stable enough for, a deeper look?
Like a quick pass-fail?
Exactly. It's essentially a quick confirmation for the quality assurance team, the QA folks, saying, okay, this build isn't so fundamentally broken that testing it further would be a complete waste of time.
Right. And the sources mention a couple of other names for it that make a lot of sense, too. Build verification testing.
Yep, that's one.
And confidence testing. It's all about getting that initial bit of, confidence, isn't it?
It is. Gives you that baseline.
One article even called it a mini and rapid regression test of major functionality. Now, that might sound a bit technical.
A little bit, yeah.
But what really grabbed me was the simpler idea behind it. It's checking if the really important features are working. And, crucially, if there are no showstoppers.
Showstoppers. Those critical bugs, right? The ones that make the software just unusable straight away.
Exactly, like trying to use an app and you can't even log in.
Precisely. Or the main screen is blank, or the one button you need to press just crashes everything. Smoke testing checks that basic core stuff. It's a fundamental health check.
So it stops people wasting time and resources on builds that are just clearly not ready.
That's the main goal. Avoid that wasted effort on something that needs to go back to the drawing board anyway.
Okay, so when does this actually happen in the whole software building process? It sounds like it's got to be pretty early.
Oh yeah, it is. Smoke testing happens pretty much as soon as new features or changes get integrated into the software.
Yeah.
And a new build is deployed to what's called a QA or staging environment.
A testing space, basically.
Exactly. It's like a copy of the real-world environment used just for testing. So think of it happening right after the developers finish their initial work, and they're sort of handing it over for the first round of quality checks.
Gotcha. So developers build something new, pop it in this testing space, and then boom, QA jumps on it with these smoke tests.
That's the flow. The QA team takes a specific, focused set of test cases. They're really targeting those essential functionalities we talked about: login, main features, basic navigation.
Speed is key here.
Absolutely. Speed and early detection. They're trying to quickly find any major flaws that the new code might have accidentally introduced.
And what if they find something? What if a smoke test fails?
Well, if a smoke test fails, the message is pretty clear. The build is considered unstable.
Back it goes.
Yep, typically sent right back to the development team to fix. There's just no point spending hours on detailed testing if the absolute basics aren't working correctly.
Makes sense. It's all about efficiency then. The sources really hammered this point home. Smoke testing happens every time there's a change to make sure the build is still basically sound.
Stability check.
They had a good example, actually. If a new registration button gets added to a login screen,
Okay.
a smoke test would quickly check, is the button even there? Can you click it? And maybe does clicking it break anything else on that login page? Just the basics.
Exactly. And what's really interesting is that passing these smoke tests is kind of the gateway. It gives the green light for the more thorough, detailed testing to begin.
Ah, okay, so it qualifies the build for further formal testing, as one source put it.
Precisely. The aim is, like the source said, to detect early major issues and demonstrate, system stability and conformance to requirements.
And just to clarify, when we say a build, that's not just the code, is it?
Good point. No, a build usually includes everything needed for the software to run the code, yes, but also data files, any libraries it depends on, reusable components, all that stuff bundled together.
Okay, clear. Now, something else the sources highlighted was the difference between smoke testing and something called sanity testing.
Ah, yes, the classic confusion.
To someone outside software, like me, they sound, well, pretty similar. What's the actual difference?
That's a really common question.
Yeah.
They're both quick checks, true, but the key difference is usually when and where they happen and who does them. Sanity testing typically happens earlier, often in the development environment.
Before it even gets to QA.
Exactly. It's more like the developers themselves doing a quick check on their own code before they release the build to the QA team. They're ensuring the basic correctness of the bit they just worked on.
So it's like a developer's personal checkup. Like, okay, did I completely break everything just now before handing it off?
Pretty much.
Right.
Sanity testing is often described as narrow and deep. A developer might focus intensely just on the specific function they changed, making sure it basically works as intended. It's their check to decide if the build is even worth passing on. Smoke testing, on the other hand, is usually broader. It covers critical functions across the whole application, or at least the major parts, and it's done by the QA team in that separate QA environment we mentioned.
Right. So sanity, developers' quick check on their specific change. Smoke, QA's broader check on the whole build's basic stability.
You got it. That's the core distinction.
Okay, that helps a lot. So let's get back to smoke testing then. Why is it so critical? Why should, someone listening who doesn't write code actually care about this?
Well, if you think about the bigger picture, skipping smoke testing, that can have real consequences for everyone who ends up using the software.
How so?
The sources point out that bugs or defects found later in the development cycle are almost always much more expensive and time-consuming to fix.
Ah, okay.
And sometimes these later bugs can become those showstoppers we talked about, the ones that can actually delay the release of the software you might be waiting for.
Ouch. Yeah, nobody likes software delays.
Exactly. So smoke testing helps set a kind of baseline quality standard right from the start. It saves a huge amount of time and effort later on. It gets the system into a reasonably good state, as one source put it, before the QA team dives into the really deep functional testing.
So finding those showstoppers early makes everything else smoother.
Definitely. It simplifies the whole process of finding and fixing those major problems later.
It's like catching a typo on the first page of a report versus finding it on page 50 after everyone's already read it.
That's a great analogy, yeah.
Yeah.
It helps QA quickly pinpoint problems introduced specifically by the new code. The sources stress that smoke testing finds major severity defects.
Like the examples we mentioned. Can't log in.
Exactly. Or you can log in, but you can't add items to your cart in an online store. Or maybe you can't even sign out properly. Those are definitely major severity issues that would instantly frustrate anyone using the software.
Yeah, if I can't actually do the main thing the app is for, it's pretty useless. Okay, so how is this actually done? Is it some super complex automated thing?
Interestingly, the sources say it's often still done manually, although automation is definitely possible and becoming more and more common.
Manual, really? I was picturing like robots running tests. What does manual smoke testing look like?
Well, picture a QA tester. They get the new software build. They then follow a predefined set of, let's say, high-priority test steps.
Okay.
They're focusing on those critical things, navigating the main pathways, trying the core features, making sure there are no immediate glaring roadblocks. If all those key tests pass,
Thumbs up.
thumbs up, the build moves on to more detailed functional testing. But if any of those critical smoke tests fail,
Back to the developers.
exactly, the build gets rejected, sent back to be fixed.
So it's a really clear pass-fail gate.
Very much so. And the sources also made a point of emphasizing checking the correct build versions. Seems basic, but you don't want to waste time testing the wrong thing.
Good point. So you mentioned automation too. How does that work?
Well, automation here means using pre-written test scripts. These are like little programs that automatically run through those critical steps on the new software build.
Ah, so instead of a person clicking through.
Right, the script does it. And the big advantage is speed and consistency. These automated smoke tests can run very quickly, often right after a build is deployed, giving almost immediate feedback to the developers.
That sounds way more efficient for those repetitive checks.
It really is. Instead of a QA person manually clicking login, check main page, log out every single time.
The script does it in seconds.
Exactly. And if it fails, developers know almost instantly there's a major problem with their latest build. It saves a lot of manual effort and speeds up the whole cycle.
Right. frees up the human testers for the trickier stuff later. Makes sense. Now, one source had a simple diagram, the smoke testing cycle. Can you just quickly walk us through that flow?
Sure, it's pretty straightforward. Step
Okay.
1, the build gets deployed to that QA environment.
Okay.
Step 2, the smoke tests are run manually or automatically.
At it.
Step 3, check the results. If everything passes, great, the build moves on to full functional testing, where they check everything in detail.
And if it fails?
If any smoke test fails, testing stops. The build is rejected, sent back to development with details on what failed. Then, once a new, fixed build is ready.
You start the cycle over again with the new build.
Exactly. Back to step 1, smoke testing has to pass before anything else really happens.
So it really is a gatekeeper.
Yeah.
Very clear. Okay, let's talk advantages. The sources listed quite a few benefits. What were the big ones that stood out?
Yeah, the list was pretty compelling. First off, it's relatively easy to perform right. That's important for a quick check.
Makes sense.
It finds defects really early, which, as we've said, saves a ton of time and money later. It definitely improves the overall quality of the system by catching those big issues up front.
Reduces risk too, I guess. Less chance of major bugs getting out.
Absolutely. Reduces risk. It also makes it easier to see how things are progressing. You get an early signal if a build is stable or not. And yeah, the big ones. Saves test effort and time, prevents QA from spinning their wheels on broken builds.
Then makes fixing easier.
Yes, because you catch the major errors early, it's often simpler to find and fix them. It minimizes integration risks when new code meets old code. And it runs quickly, giving that fast feedback.
That is a strong list. It seems like a no-brainer, really.
For most software development, yeah, it's considered essential practice.
The source material also gave some specific examples. Sample smoke test cases. Can you remind us what those were?
Sure. They gave 3 clear examples. The first was about logging in with valid credentials.
The basic entry point.
Right. Launch the app, go to login, enter correct username, password, click login. Expected result, successful login. And in their example, that's what happened. Pass.
Okay, fundamental check passed. What was next?
Second one was testing adding an item to a shopping cart. So browse, pick a product, try to add it to the cart.
Core e-commerce function.
Totally. Expected result. Item added successfully. But in their example, the actual result was a failure. Item wasn't added.
Ooh, big problem. That's a major fail.
Huge showstopper for an online store, yeah. So fail, build rejected.
And the third one?
Third was checking sign out. Find the sign out button, click it. Expected result, users logged out. But again, in their example, actual result, failure. User wasn't logged out.
Another critical fail. You need to be able to log out securely.
Definitely. So these simple examples really show how smoke tests quickly hit those critical paths and can uncover major issues. Can't buy things, can't log out before anyone wastes time testing, I don't know, the color of a minor button.
Right. Focus on the foundation first. So this really brings us to the main takeaways, doesn't it? What's the bottom line from the sources?
The absolute key takeaway was that smoke testing should be done on each and every build without fail. It's that crucial first step to catch defects early. It's like the final check before a build moves into the more serious system stage of testing.
And it's not just for brand new software, is it? It applies across the board.
Correct. It applies to new development, yes, but also to adding major or minor features to existing software. Any kind of release, really.
Yeah.
Any significant code change needs that smoke test.
Got it. And verifying the build versions, simple but important.
Super important. Don't test the wrong thing.
So wrapping it all up, smoke testing is a fairly simple process, doesn't take much time, tests basic stability.
Can be manual or automated.
And the main goal is to cut down wasted test effort and ultimately boost the quality of the software that we all use every day.
Precisely. It's a foundational practice. Helps prevent a lot of headaches down the road for the developers building it, and importantly for the end users, like you listening right now.
So there you have it, our deep dive into smoke testing. Who knew something that sounds kind of technical could be so, logical and have such clear benefits?
Yeah, it really highlights how valuable those initial quick checks are in any kind of complex process, doesn't it?
It really does. And what's fascinating, as you kind of touched on earlier, is seeing those core ideas, early checks, basic stability pop up everywhere, not just in software.
Mm-hmm. You see it in manufacturing and project planning. Any complex system, really. There's usually some form of initial check to make sure the basics are right before you commit more resources. It's about catching errors early, managing the process efficiently.
That's a really great point. It makes you think, especially, considering how much software touches our lives now. What are the sort of invisible smoke tests we rely on every day?
Yeah.
The things we just assume will work before we dive deeper?
That's a fascinating thought to end on. What are those implicit checks we all do?
Definitely something to mull over. Thanks for breaking that all down.
My pleasure.